In this application, we're going to be looking at the AP820-5, and it's the red laser, and it has a 5mm depth of field and between a 4 and a 5mm laser line, and we're going to look at profiling this very reflective metal surface. And as you can see, I've got it a little at an angle, just trying to capture that angle somewhat. And so let's go ahead and shrink that photo. And I've also got the laser on a little linear slide with an encoder so that we can pick up some profiles of on this application. So here you can see is the signal we're getting. Each of these is 2 millimeters, or about 80 thousandths. And as we zoom that up, you can get more of an idea of what that surface looks like. It is a very difficult surface, being very reflective like this, which is always of a concern when you're using laser triangulation. And as I'm moving it back and forth, you can see that we're seeing some of these surfaces. I would suggest that we probably use a little bit more accurate mechanical staging and maybe do a little bit more thorough proof of concept, just to make sure that we are getting good, valid data. You know, this is sort of a quick bench test to go ahead and look at what that data looks like. And let's just zoom it up a little bit more. Each of these is 1/2 millimeter, or 20 thousandths of an inch. And of course, you can see right here where it crowns and it starts to go over the side of that. And we should be able to, I would imagine that having dual lasers coming in, to be able to pick up that side surface and also use it to calculate the thickness of the target. And if we looked at, let's just take a look at, see if we can get a better signal. See if we can get a little bit better signal on this. So here's that end section, and we're coming straight down on it. And as you can see, I don't have the fantastic fixturing here for this kind of accurate measurement, but it's giving us a sort of a real quick idea of the number of pixels that we're going to capture. And of course, we do have some settings where we could come in here, and this is what the software would do. It would actually do some what we call feature measurements. And this is where we would use these features to come in and actually measure in this case, if we measured the width, and we feature 1, if we had it, we'd put it on the left edge, and feature right on the right edge. And so then it would calculate this length right here of about it looks like about 0.43 millimeters. And we're just getting a little pixel jitter there as we're making this measurement. And of course, that can be filtered out with a lot of software. So just a quick example of how you would do that to measure that thickness of that part. And let's go ahead and clear this. And let's look at let's go and look at the 2D view, or 3D view, excuse me. And if we came in here and started capturing some of that live data, you can see over here in the screen that we were sort of doing a real quick profile with that encoder across there. And if we came in on static points and we were to look at this, you can see that we're measuring that thickness of that metal strip. So in summary, I would like to probably do a little bit more accurate scanning and to be able to verify that we're getting the measurements that we think we are with this line sensor.